Welcome to the Bug Hunters Cafe. Have a seat anywhere.
Thanks. Hi, Jason.
Hi, Bojan. Who are we meeting with today?
Moshe Zadka. They've been involved in open source since 1995 and Python since 1998.
Oh, right. I met them at a conference, I think. They're a core contributor, one of the founding members of the Python Software Foundation, right?
Yeah, co-founded Twisted as well. They've been doing site reliability engineering and Devops since before those had names.
Wow.
Yeah, maybe they can explain what the Devops is.
Yeah. I don't think anyone actually knows what DevOps is except DevOps. Top secret knowledge somewhere.
In any case, they'll be running using teleporter soon.
Cool. Wait, teleporter? We have a teleporter?
Sort of. It's a fax machine.
Oh, last I heard it was low on toner.
Johan assured me it had enough for one job.
That stuff's getting more and more expensive. What's it made of? Unicorn tears? It's a figure of speech. Don't get your tail in a knot.
Oh, here they are now. Hi, Moshe.
Hi, how's it going?
Great, it's good to see you.
Yep, good to see you. I'm so glad I found the transporter in the Computer History Museum so I can get here.
Computer History Museum, where's that at?
Yeah, that's in Mountain View. It's a really great place. When this is over, we can all go there and have so much fun.
Well, I mean, I'd certainly be up for it, but do you mind if we take my my ride? It's the coat closet in the corner. It's not stationary.
Sure, that sounds good.
I'm a little flighty about the fax machine because I don't want to try and get back that way today for obvious reasons.
Yeah, that sounds like it can get dicey.
Yeah, I spent a week kind of faded, and that was not fun. Had to find someone who could kind of darken me, and Photoshop filters do not do great things to your complexion.
I bet they don't. You should have used Pillow, clearly.
Yeah. Well, I mean, word to the wise: if you ever need to, fix up your complexion, not in a photo but in real life, use Python. It's Python's import anti-gravity while you're at it and fly. It's awesome. Hey, can I get you anything? Coffee's on Soft Terrific. They're the ones who sponsor these talks.
Yeah, I'm probably gonna stick with tea, Earl Grey, hot.
Oh, okay. Yeah, I'll go get that.
Hey, is that Margaret Hamilton over there?
Officially, we know nothing.
Because, she's awesome. Could I go talk to her for a minute?
One word: paradox.
Okay, I would have really loved to talk to her about the how the recovery code in Apollo 11 worked. That was such a great job.
Yeah, I'm sure that would be fascinating if that were Margaret Hamilton, but that's officially not Margaret Hamilton.
Okay, well, I guess I made a mistake.
Here you are. There's your Earl Grey.
Good.
So, we were talking about it a moment ago. While we're waiting for you, what exactly is DevOps? I think everyone's got their own idea of what it is, but everyone's afraid to ask because they don't want to look like they don't know what they're doing.
Yeah, I guess the first thing I'd say is never be afraid to ask. Nobody knows what they're doing, but then there's a reason why it's complicated because it's been overloaded a lot, and so it's very subtle. So in the beginning, right, what it started was it wasn't a job description; it was a movement, which the idea is to break silos apart. So to understand what silos it's talking about, right? If you have the old model of software development, you have the programmers working on code, and then they throw it over the fence to the operations people. The operations people try to run it, monitor it. Sometimes they, when they see a problem, sometimes it's because they misinstalled or there's a transient problem on the hardware. But on the other hand, sometimes there's problems with the actual code. So whenever they see a problem, they have to diagnose it, figure out if it's something on their end, on the operational end, or if it's in the code. If it is in the code, they have to somehow give a reasonable reproduction to the developers. The developers try to fix it. And this whole kind of back and forth is very slow, but even worse, right? Because we're all people, right? It gives a strain on the relationship, right? Because at the end of the day, it causes a lot of finger pointing, right? It's your fault you didn't run it correctly. No, it's your fault you didn't write the code correctly, and
Yeah, we have the whole
you
get blame thing going on there.
right. But it's even worse than Git blame, right? Because some of these things aren't in Git, right? Some of these things are in environment, so it causes kind of these flare ups between teams, and it gets kind of very political, and it's unpleasant on everybody. Especially again if you think of like the classic organizational structure, where the developers and operations might not even be in like the same group, right? So the kind of only shared management structure there is a CEO, which clearly no one wants to bug with, like some small bug in whatever, like the web platform or whatever. So it mostly it ends up with fights and who shouts the loudest, and clearly this is not a great way to work.
No.
The idea of DevOps is let's make it one team, right? The developers and the operations people, and this is very subtle because sometimes people approximate it to the developers run their own code, and well, it's not a wrong way to do DevOps. That's not the only way to do DevOps. The main issue here is let's have the developers and the operations people be in the same team, work together. And then I say a DevOps engineer is one who can, build these kind of teams, right? One who understands enough of the development, enough of the operations, and they'll be a useful glue. And this is why it's kind of like different things to different people, because some people think of the movement and of the philosophy, and some people think of the job description. And eventually, a lot of people who didn't do DevOps just said, we want someone with that kind of skill set, even though we don't do proper DevOps, so we don't do DevOps all the way, but they still call it DevOps engineer. But ultimately, DevOps is the idea that someone has to understand enough of the code and enough of the operations environment to make sure that they work together well and to be able to communicate between the people working on different sides. So that was a very long answer, but I think this is partly why people don't understand it, because they always expect the answer to be short.
Well, sure, and I think a lot of times they think that DevOps just is a synonym for QA.
I actually thought DevOps is a synonym for Docker.
and this is all part of it, right? Because Docker is in many ways a technology that is really built around the philosophy of DevOps, right? Because you take the code and you take kind of the dependencies of the environment and you put them together in one big thing. And you cannot really use Docker correctly unless you have a DevOps organization, because then you'll have some people building the Docker thing and some people building the code, and you don't gain anything at that point. Why not just use Ansible or Salt instead of that? So, and this is why this is the confusion, right? Because there are tools that are optimized for a DevOps oriented organization. In general, these are good tools, but using these tools does not make you DevOps, and using DevOps does not have to use these tools. But it's kind of a Conway's law, right? These tools are optimized for the kind of organizations that use Conway, and so there tend to be a high correlation.
Well, I mean, it makes me feel a little bit vindicated because I've been doing basically that under a different name. I didn't dare to say DevOps because I'm thinking I don't understand DevOps well enough to. You pull up the Wikipedia article and it's this long, dense, kind of cerebral explanation. You're like, this just hurts. It just hurts my soul. So, I just kind of rolled with the idea that, okay, I don't really understand what DevOps is, except it has something to do with the code running and building and the whole team being able to function in that context. So I just let that go. But what I've been doing at my team, maybe you can tell me if I'm doing this wrong, is especially because the team at Mouseplow Media, it's just interns, actually. It's an unusual company. And, we're kind of a springboard for people starting careers. And so we're all 6-hour-a-week interns, with one exception being myself. And so what we wound up doing to answer this whole problem of, DevOps and QA and all this other stuff is that everyone at some point or another is going to get experience in how the build system and the CI pipeline and all this works. But we have one volunteer at a time who serves as the repository master, and they're kind of the ones who have the the keys to go kick the tires on everything. They can push past the normal quality control systems in case something breaks. But only one person at a time has those privileges, and that baton gets passed around depending on what people are working on and who's feeling in the right place for it, and who just wants to not have to mess with the pipeline and get to do the code. And so we don't have a dedicated QA department. It is the developers, but we have that rotating role.
And that's certainly one way to do DevOps. There's lots of ways to do DevOps, right? As long as you're fighting against silos, then you are doing DevOps. And like I said, the job of a DevOps engineer is to, help make sure that, all of this works. And sometimes it's help make sure by writing a good build system. And sometimes it's help make sure by saying, hey, let's have a meeting and talk about how we're doing that. And sometimes it's, hey, I'm going to organize a brown bag and teach you all a really important skill, right? So all these parts are the parts of a DevOps engineer, right? So there's communication, there's education, and there's actually like writing code, or like the actual engineering work. And so DevOps engineer at a lot of times, right, even though it sounds like it's all about computers and operating systems and figuring out performance or reliability issues, the main part of the job is about people, right? Like a DevOps engineer, the main focus is the people around them, right? The developers, the operations people, if you have dedicated operations, the QA, security, if you have dedicated people for that, right? Communicating with all these people and making sure that they're all coordinated. This is the most critical part of the job. So I always say, you have to be really good at understanding how operating systems work. But the most important skill set for DevOps engineer is people skills. They're not optional. They're like a critical part of the job description.
Well, I mean, isn't that arguably true of all developers? Should be anyway.
It is, right? And definitely communication and people skills are always really important. But I feel like in DevOps it's really, really important because you have to communicate with a lot of people who are very different from you, right? In their skill set and background and experience level. So having this kind of very strong sympathy for other people, right? And I'd like to stress sympathy and not empathy. I don't think empathy is a good model. I don't need to feel what other people are feeling. And in many ways I can't, right? If there's a junior engineer, the last time I was a junior engineer was 20 years ago. I don't think I can really understand how they think, right? Or feel what they feel. I definitely have forgotten long ago how that confusion feels. But so if you count on your empathy skills, you're gonna lose, right? What you need to count is on your sympathy skill, right? So it starts with believing people. Right? It starts with saying, if they say, I don't understand it, the response should not be, how could you not understand it? This is super simple, right? And it's kind of relating to their emotion. It's caring about the emotion. It's caring about them, right? And I think this is where I put this is my biggest soapbox, right? Because if you look at the internet, right, a lot of people who have thought about it will kind of keep talking about how DevOps people should have empathy. And I fundamentally disagree with that. DevOps people should not concentrate on empathy, they should concentrate on sympathy. Sympathy is how you solve these problems.
That's quite interesting. Usually, when I talk with DevOps people, they say, oh, DevOps is easy because you only talk with developers. You don't talk to actual humans. Because, yeah!
Well...
Thanks.
Well, but that's exactly the problem, right? Expecting developers not to have feelings or emotions. There's so many ways it's bad, right? And this may not be even the biggest problem, but the obvious problem is there's a toxic masculinity involved in that, right? Which is developers should behave quote, real men, and real men should never display emotions. That's bad for people of all genders, right? It's it's not even just bad for women who are clearly impacted by that. It's not good for people who are perceived as male and have to keep their emotions under control. It's perfectly okay to be frustrated and even at the point of tears if you worked on something a long time and it crashes in a weird way that's frustrated you for 2 days. It's okay to have emotions, right? It's not a problem. And again, like that's why I stress sympathy, right? To understand that that person, really has feelings, and until you're on board with acknowledging their feelings, you won't be able to help them solve the technical problem. Then you're not going to be able to solve the technical problem.
And of course, that leads into my then asking, how does this whole DevOps philosophy then tie into bug hunting? I mean, that's one of the main things we chat about around here, and it's obviously this has an effect when it's not just this one QA department locked in a room with a pizza and a computer
Yeah.
trying to find the bug.
Right. So yeah, and so that it, you're right. Like this, like part of breaking silos is figuring out how do we hunt bugs in a way that's better organizationally, right? And sometimes it means I'm gonna hunt the bug myself because I feel like this is a complicated, cross-cutting enough concern that I'm just gonna help find it. But ideally, that should be the last resort, right? Like one step down from that is education, where I'm like, you know what, I'm gonna hunt that bug myself, but I'll grab one of the developers who I feel should have the skills or is close enough to having the skills to hunt it, so they can look over my shoulders, virtually if we're remote, or physically if we're close together, and show them how to do that, right? So that's education, right? So first it's like, like the last fallback is engineering. I'm actually going to find the bug. The second is education. But even before that, maybe we can just make a process where bug hunting is not going to be unpleasant, right? So a DevOps engineer's job is to, again, talk to the team and figure out a good monitoring strategy. So when the problems happen, we have good details about them. It's to talk to the QA department and figure out what tests we can automate so they can run automatically, so we can do, all kinds of Git bisections, right, or all kinds of fancy stuff like that, right? It's to maybe talk to the QA department about doing chaos stuff, because that often helps find bugs, right? So the first thing that like a good DevOps engineer would think about is, how can I just make that problem easier in general? What kind of processes can I help put in place that will just make bug hunting easier? And all of these things work together, right? Like after I find the bug, maybe the next one that's similar to that, I'll have someone to kind of go along. But the first time I'm going in it, it's maybe easier for me to kind of just not think about anything else, just finding the bug. And after we find a few bugs like that and the team feels confident, we'll talk about how do we improve the processes. So it's kind of going up and down this stack. But yes, bug hunting is a critical part of DevOps. But thinking of that in terms of DevOps requires not just thinking about the bugs, but again, about the organizational structure and the people involved.
I can personally vouch for the benefit of debugging with someone who may be considered more junior than myself. I think some developers would be hesitant to do that because, I just want to find this bug and I don't want someone with less experience slowing me down. I find it usually speeds me up because I've had a few occasions where I had an intern that I was training and they're helping me debug, and of course by that point I'm code blind. I've been in the code for so long I can't see which way is up, and they come over and we work through it, and I might throw some suggestion out there, and actually one of my interns caught me a couple of months ago. I said, well, wait, this fix you're going to do, you shouldn't do that because you just said you don't know why you did it this way. You had to have some reason to do it that way. Sure enough, he was right. I was fixing the wrong half of the problem, and I would have actually created an additional bug on top of the one that was there. For crying out loud, my mother, who's also my business partner, she's not even a coder, and one day she walked in while I was debugging, and she looked over my shoulder and went, "Isn't that supposed to have a semicolon?" Well, thanks. You just saved me another 2 weeks.
Definitely. And also, often, again, because you're debugging and you're improvising commands, sometimes you make a mistake in writing the command and you get the, data that you act on, but it's actually, invalid data because you got it from the wrong place. And someone, even if they're pretty junior, can say, hey, isn't that command supposed to, look at that cluster, not this cluster? Like, oh God, yes, you're right. I'm basing all my hypotheses on data that is irrelevant to the problem.
It's an insurance policy against tilting.
Yeah, oh, definitely. Like, because again, you're stressed, and often, there's a time limit, and kind of a lot of pressure. So, definitely, sometimes it's worth working with people. Even when I don't work with someone, I'll often find a way to kind of um, put my stream of consciousness in a public place. Like, it might be a Slack thread, or it might be comments on a ticket. And then I say anyone who wants to look at it can just see my stream of consciousness. And then sometimes, they'll like DM me on the Slack, why, what are you doing? Stop, stop, stop. And usually when people say that was a good idea to stop and think.
And I think honestly it is worth defining though, because I've caught a phrase that we've used a couple of times in here that maybe isn't very well defined either. Like we use DevOps as silos, so to avoid angering anybody in rural communities. We're not talking about tearing down your grain store.
We're not.
Oh, God, that's fine.
No.
No, we're all big fans of grain. At least I'm a big fan of grain.
Oh yeah, grain is wonderful, but it's all about not having this hard separation where the people in this room and the people in that room don't even know each other, can't even
Right.
function as a group. They're two separate departments that are somehow supposed to be working on the same thing, and that can create a lot of problems.
Yep. No, it's good that you pointed out. Yeah, I should have also explained my terminology. So thank you for that. Yeah, silos basically refer to the fact that just like grain silos, right? Like if you put different grains in different silos, that's a good idea for the grain, but that's a bad idea for people. Right? So silos are great for grain, not a great model for how people communicate.
So great insight number 275: people are not grain.
That's and we kind of joke around about it, but it's really important sometimes to understand that, like, some things that we can think of, like, good or bad, they're very context dependent, right? I once like I had a talk about like how to think about tutorials, and I said that while of course in some places we really want diversity, right? We really want gender and racial and ethnic diversity when we talk to people. When you are giving a tutorial, you don't want experience diversity or specialty diversity, because then you're not servicing everybody fairly, right? You'll end up focusing. So diversity, while generally we associate it with good stuff for good reasons, right? There are kinds of diversity that in some cases you don't want. So like words are contextual, right? They have meaning, but they also have context.
I never look at it that way, but it makes quite a lot of sense.
Well, yeah. When you give a tutorial in Python, unfortunately, this is like the most. Well, unfortunately, in Python, while there is diversity, and of course they're working hard on improving that. You don't get great necessarily racial or ethnic diversity. You will get a lot of experience diversity, right? You'll have people who come in as web front-end people and back-end people, and more like SREs and data scientists, and they'll all come to the tutorial, and then you realize that you can't talk to them, right, in the same language, right? Different people understand things different ways, right? So and this was one of when I gave a talk about how to give tutorials with Python, I was pointing out this is one of the challenges that you'll have to think about how to overcome.
Hi, Bug Hunters Cafe. Marta speaking. Absolutely. We're open 24/7 at bughunters.cafe. You can also find us on Twitter, Dev, and Instagram as Bug Hunters Cafe. You're looking for who? I'm sorry, I don't see anyone who fits that description. If I see him, I'll tell him you're looking for him. Yes, you're welcome. Live long and prosper to you too. Goodbye.
Who was that?
Someone asking if we've seen a cranky Scottish starship mechanic around.
So we've talked a lot about DevOps. Something else that you mentioned you have experience with is SRE, which I'll admit is something else I know absolutely nothing about. I don't even know the definition of.
Yeah, and I guess it's kind of weird because it also kind of like, is a little bit like DevOps in that there's like, different ways of thinking about it. It's just again, to make sure that we're clear, it stands for Site Reliability Engineering, just to kind of unpack the acronym. And the idea was that I guess a lot of people felt like DevOps put a lot of emphasis on the skills of operations. So the idea of Site Reliability Engineer is to have more or less the same kind of people doing the same kind of role, but with more stress on like the software engineering side rather than the operational side. So a lot of time SREs come from more traditional software development background, but they kind of specialize in a different kind of engineering, which is maybe a bit more similar to DevOps. But the idea that these are people with like the full stack of software developer skills, right? You expect them to know language really well, to understand, kind of like the basics of algorithms, to understand unit tests, all of these things that sometimes people who come from more operational background take more time to catch up on. And the reason, that started was because, again, this kind of started as like a, I guess, if you look at where it started, right, it's kind of very telling. It started in Google. And the reason it started in Google was because Google is one of the first, big famous scaling stories, right? And as you scale, you have to scale out your operations. And the only way to scale out anything basically in this world is to automate it, which meant you needed people who thought about software development, but who specialized about software development that focuses on automating operations. And that kind of like led to like the idea of this is like a different engineering specialty. This is a site reliability engineer and not a software engineer. And in many ways, these two terms can be used synonymously. And I think people who get too hung up on like the differences between them are just focusing on the wrong thing, right? What you need to focus is what kind of problems you're solving. And sometimes you need to concentrate on like the term if you're trying to hire people and you want to make sure that you get the right kind of resumes. But ultimately, I feel like in practice, I've had positions which were identical, in like my day-to-day responsibilities, which were called site reliability engineers, DevOps, system engineers, and production engineers, and honestly, like software engineer, right? Because some places just don't care. So your title isn't the thing that matters, right? But there is a different stress maybe when you think about site reliability engineering, that you start thinking in terms of more automating operations, and often that leads to like how to think about debugging, right? Like sometimes, again, if you're debugging something very in a scalable environment, you can't just look at random log lines and kind of compare them, right? You might want to have to write a specialized analysis code. So I guess one of my favorite stories about that was we use a caching tier that's composed of like a bunch of Memcache servers and a bunch of MIC routers in front of them. And that's a very typical caching tier. It has a bunch of good things about it. But ideally, like at the client side, you kind of just connect to MIC routers randomly. But that's not what we had at that point. What we had was that the clients thought they were talking to memcaches, which meant they were connecting to all the MIC routers and trying to send the right key to the right MIC router, even though it didn't matter. And that was okay. We knew that, and it didn't bother us too much. There were downsides, but we were like, we're going to fix it, but we're going to fix it later. It's not an urgent issue. What did kind of like, potentially was an urgent issue, we launched a new data center. And we knew that this data center had like potentially performance problems, so people really kind of looked tightly to see potential performance issues. And we saw that one MIC router in the cluster was slow, and that was weird because like they should all get the same keys, right? Like the keys are hashed and they're hashed to all the servers. There's a bunch of them. There's enough keys, why did this one Mac router was slow? Why is it getting like a super hotkey or something? And like, but the hotkey would make it faster. So we kind of really try to dig into that. And there's enough Mac routers and enough data there that you can't do it in your head. You can't just, grab the metrics data and start computing that in your head. So what I did was I grabbed the metrics data, pulled it into Jupyter and started to run analysis. And kind of try to kind of dig into which one it is and how much slower it is and when does it show slowness and does it show keys. And so I also grabbed like a sample of keys and tried to figure it out. And like, because I had all this software development experience and could write code that would slice and dice the data. Eventually what I found that like the reason it was slow was kind of an optical illusion.
Really?
Yeah, it's really weird, but yes, it was. Well, I guess I should say maybe a metrical illusion. The way we counted slowness was we averaged the time it takes to get a key, and that means that you can be slow if you just get slow keys. And the thing is that all the other Mac routers had one hotkey, and that hotkey really kind of improved their average. And that Mac router, it was handling less traffic, and it was actually handling it, really, in some sense faster. But the average was slower because it didn't get the artificial boost from handling a super hot key. So, eventually, I was here's the data. It's not a problem. And once we move to correct usage of Mac routers, it won't be a problem at all. But it's not really a problem. It's just an illusion in how we measure the data. And but it is. It was really these kind of illusions. Unfortunately, are really really common because often to get good measurements from high performance system, you take shortcuts in how you take these measurements because you don't want the measuring code to slow down the real production code. So these kind of metrical illusions, if you will, are not as uncommon as one would hope for.
Well, and I find that interesting that, we were talking a while back, Bojan and I were about how you can put a $2,000 debugger in front of a developer and they're still going to use print statements. And so funny how you're describing doing all this stuff with the metrics in the Jupyter notebook, and it just reminds me of the fact that it doesn't matter how sophisticated the tooling is, we're still ultimately going to go back to some form of a print statement, even if it's a print statement as part of a statistical analysis in the Jupyter notebook. We're ultimately going to go back to that.
Sure. I agree, but if you look at the alternative, right? The alternative is usually people will go into say something like Prometheus or any of these SaaS thing and start writing more and more complicated queries in these I don't want to say bad things about these languages because they're very well suited for what they do, but if you start writing a Prometheus query that's 3 lines, give up. It's you're clearly trying to abuse Prometheus. Just write a smaller query, grab the data via an API to Prometheus, and then munge it. You'll have a better experience, right? Because Python with Jupyter is a really good language. I call it small data because it's not really big data, right? You're talking about computers, right? If you have 100 computers in a tier, that's a pretty big tier. But even if you have 100 computers and you have 1,000 metrics for each and whatever, it's less than 1 million numbers. Python does it without even bothering with NumPy pretty fast, right? But on the other hand, a human is, of course, it's way more than any human can look and see. Sure. So this kind of small data analysis in Jupyter is a really, really cool kind of secret weapon. Because people think of Jupyter as a data analysis tool and usually make it synonymous with big data, and we don't have the kind of data that Jupyter is good for. But no, it's still good for that stuff too.
That's an interesting way to look at it, definitely. And speaking of Python, you're one of the you're one of the original Pythonistas. One could say.
I've been using it since '98. Back when Chido was still on Python list. There was no even Python dev, right? Chido was just on Python list, and if you commented on something, he would just answer. I remember one time I sent an email saying the person who wrote the poly module appeared to know neither polynomials nor Python, and Chido's answer was it was me. So I learned a lot about how to communicate with humans. Since I think I was like 19 at the time, so I guess you can forgive me a little bit. I was
Yeah.
young and didn't know what I was doing.
Inadvertently told Guido van Rossum he didn't know what he was doing.
Yeah, and to be fair, the core thing was actually like the technical critique was actually accurate, right? Chido didn't have a lot of experience in polynomials, and this was like a finger exercise, and it was just not using kind of properties of polynomials that would have made the code much more elegant and much more efficient. And at the time, like this was in Python 1.5.2, but this code was written in like Python 0.9 and barely touched. And that's why it kind of also didn't look like it was really using good Python skills. So like I had a core critique that was technically accurate, but definitely since then, in like the more than 20 years, I have learned a lot about how to communicate these critiques in a way that's more amenable to people actually addressing them.
Yeah, the whole thing about less blame, more sympathy.
Yep, definitely.
I noticed too that you are one of the developers of something called Twisted, which some Python developers will recognize as being I guess you could almost say like the father or the grandfather of asynchrony in Python.
And like it's so funny because like in the old days we were like we would really love to communicate to like the core Python development team what kind of language feature would be useful. And while it took a few iterations, eventually, we got keywords like async await, and now you can use the keyword async await now in Twisted because they're just keywords in the language. They don't have anything to do with the async IO framework. So, from the perspective of a Twisted developer, having async IO really made Twisted better because it puts the right sort of pressures on the language to have the right support for asynchronicity, which Twisted could then take advantage of. So modern Twisted code actually also uses these keywords.
That's quite interesting.
I think a lot of people don't know that, and I think partly it's our fault. We haven't communicated it well. But on the other hand, part of it is like there was like this kind of meme of like async IO is a replacement for Twisted, and I think that's not a good model to think of. Async IO still, can't do some of the things that Twisted does well, which is even not a problem, right? Like Twisted A had more time to develop, and B, because of how stdlib in Python is tied to the Python version, we can iterate on Twisted much, much faster than async IO can iterate. Because if we build like a new feature into Twisted, people can use it right now. They don't have to upgrade to the next version of Python. If someone checks in a new feature to async IO, you have to wait until like that version of Python is released, right? So I think Python 3.10 is already kind of in like semi-feature freeze, right? You wouldn't be able to even get it in, so you'd have to get into 3.11 and then wait until it's released, and then no one can use it unless they move the whole project into Python 3.11, which ideally people do fast, but in real life it takes time. On the other hand, the only thing that you need to do to use the latest version of Twisted is change one line in your requirements file. So Twisted has this advantage, this inherent advantage over async IO, that it had more time to develop and it can iterate much faster. So there's a lot of things that it does that still you can't do for async IO. One of, I guess, my pet peeves, because I actually had to go through that because we used async IO in something that it didn't make sense for me to come in and switch the whole thing to Twisted, and I had to write a unit test. And wow, I haven't realized how much more fun it is to write a unit test for Twisted stuff than it is for for async I/O because we built a lot of really, really cool features for unit testing async code in Twisted.
Yeah. I recently started my first Twisted project, so I'm still going around and figuring what is the best way to write tests for asynchronous code, because up until now I've been mostly working with synchronous or using threads, but asynchronous code is a very new area to me. Any advice?
Yeah, which is basically, in some sense, don't. But you know, to make it more, if you write your code with Twisted the right way, and by the right way I mean you have everything except a reactor, you don't use the global reactor, then you can use a custom reactor to make sure that even though it uses async, the outer layer just treats it as a deferred, and the deferred will have a value already because your reactor can be immediate, and then you can just the unit test itself can just be a regular unit test, right? It needs to advance the reactor. If you look at some of the unit tests in Twisted itself that use clock, twisted.internet.task.clock, then you can see like what I mean by having a fake reactor be a very powerful tool for writing unit tests, where the unit test itself doesn't have to understand anything about asynchronicity. You just use the fact that Twisted can convert futures to deferreds transparently, and deferreds you can use from sync code just by accessing them, assuming they already have the data.
Well, that's a quite good advice. I'm gonna start using it.
Thank you.
Also, how do you debug asynchronous code? In my experiences, I was every time I start doing debugging or try to isolate the code, what happens quite often for me, since I don't have much experience, is that I end up in a state where one of the asynchronous sides is waiting for another to respond, and another side is broken. So basically, I have to kill the whole code.
Yeah, I guess I don't use debuggers all that much. I usually use print statements and like sometimes the fancy print statements, right, log statements. But honestly, like that's part of the reason why it's such a powerful technique is because you can just do that. But I guess the other thing I will say is that Jupyter uses async I/O as its internal loop. Twisted has the async I/O reactor, and if you put everything together in exactly the right way, you can write small parts of your code inside Jupyter and kind of access the data in real time. That's a pretty. If you want to see like an example of, I'm not showing debugging at least, but I'm showing a lot of similar things. I gave a talk in Python WebConf 2019. That's recorded, so we can put the link in the show notes where I show some of these techniques for writing a web server. But honestly, like the real reason to use some of these techniques is you can put small parts of your code, run them in Jupyter, and then kind of interact with your code on a much deeper level.
Mm-hmm. Yeah.
Yeah, I think the whole idea of using Jupyter for debugging is still I don't know why that's such a novel thought to me, but I'm sitting here thinking that that's genius. Why did I not think of this before?
So I guess I'm kind of a Jupyter fanatic, to be very fair. I also wrote like a series of articles about Jupyter that eventually got made into an ebook, which covered all the way from using it as, we talked about Photoshop earlier, all the way from using it as a kind of alternative to like an image manipulator, because honestly, I don't know how to use any of these, right? Not just Photoshop, but Glimpse or any of those. I'm just not good at it. So I'm good at Python, so I use it as like, my alternative to Paint. And like, you can write UIs in it, right? So I also use it to like write my daily journal.
Oh wow!
It's like such a powerful tool that it has so many uses that I really think, like, yes, it comes from data science. Obviously, it's great for data science, but it can do so much more. I also gave a talk in SRECon about basically using it as your main incident resolution tool. Partly because you have the notebook, right? So you have the list of what you've done, and basically at that point, for the prep to the retrospective, all you need is to add, like, kind of cells with markdown that kind of like have the pros of, like, what happened and some context, and you already have the document that you'll have for the for the retrospective, right? So, like I said, I'm kind of a Jupyter fanatic. That's like usually the first tool I use for pretty much anything, right? If I'm not sure, like, like if I'm working on some application that I don't understand, I'll put like a Jupyter kernel in that virtual environment, open it up in my Jupyter, just call random functions with random arguments to just understand what's going on. So Python is like a super weapon, really. Like, if you don't use it, then you're basically depriving yourself of almost a superpower.
And I'm feeling really stupid now because, like, I just finished writing this whole book called Dead Simple Python, and I talk about Jupyter Notebook a little bit in there at the end, but I'm mainly focusing on just the core language. But the whole time while I'm writing this book, I keep going into the shell. And I'll tell you what, it's really hard to fix mistakes in an interactive session, and I'm kicking myself because I worked on this book for 3 years, and I could have gone and done it in Jupyter and saved myself hours of retyping.
Maybe you should write like a kind of a sequel, or like a like a little, like, like a 50-page kind of how to use Jupyter for all of these things, right? And you can but like, so I wrote a book called Devops in Python, and one of the things I talked about was the different shells, but I really kind of talked a lot about Jupyter. I really feel like people underestimate what Jupyter is good for. So, like I said, I'm a Jupyter fanatic. I probably overuse it, but I think right now it's a better error to make to overuse it than to underuse it.
Yeah, I'm definitely in that category of people who underuse it, because I use it mainly for data science projects, and they're just for debugging stuff and seeing, okay, this algorithm is working nicely for this solution. So I'm just gonna write that into Python, and then I don't use Jupyter at all. But your perspective on power and all the possible usability of Jupyter is completely new way of looking at the things, at least for me.
I wanted to ask you, what is the weirdest bug you have ever encountered?
Oh, I can definitely talk to that, because I think it also, like, it's kind of an interesting story relating to, like, what we talked earlier about, like, junior engineers and stuff, because that is a bug that I was handed. I ended up not, like, I'll kind of spoil the story by saying I didn't reach the end. I never got to diagnose it and figure out what was going on and how to fix it. Eventually, for all kinds of reasons, it was handed on to, like, one of a more junior engineer, and she actually did a great job, and I was really interested to see her final stuff. So the the symptom is the Python process doesn't shut down, right? It calls sys.exit, and for some reason it stays up. And we tried everything we could think of. We kind of had the process kill 9 to itself, and that didn't help. And we were, like, really, really frustrated. And I had no idea what I was going on. And eventually I moved on to another project. And she figured out that the problem was that we were using both multiprocessing and multi-threading. And some of the threads were not daemon threads. So the other processes that kind of got spun off from the multiprocessing had kind of threads they didn't have anything to do with, because when you spawn a process, it also spawns all the threads for it. And some of those threads were not daemons, so they were still doing their thing, but we didn't need them to do any of this thing, but they still kept the process running because it had a non-daemon thread. So that was definitely, like, kind of like this kind of weird, like, I think the bottom line is never use multiprocessing and multi-threading in the same code. Honestly, it wasn't justified. I was kind of thrown into that project. But if you do end up using it, be aware there's a lot of weird corner cases to handle.
Zombies.
It's worse than zombies, right? It wasn't a zombie process. It was a, from the perspective of the Linux kernel, it was a live process.
So it was alive and yet really should be. So it was a lich. Is it even a lich? Leech?
I'm not sure. Like the technical term for that. If
well,
you
it's
have
not
a
even
process,
a technical term. It's from fiction. Lich, and I'm sitting here,
Oh, yeah.
and I can't even
Yeah,
figure out how to pronounce it. My
Yeah.
best friend's gonna be so he's just gonna be
Oh
shaking
yeah,
his head with his hand over his face.
I did play D&D like a few million years ago, but I think it's probably Leech. Anyway, now that I know the concept, yes, it's like this really weird thing, right? That like it's kind of not supposed to happen, but of course, everything happens. Eventually, right? If you do weird enough things with code. So yes, it was like this weird, like it's not even zombie, right? Because at least zombie shows up in PS as a Z, and then you can figure out why it's not being ripped properly. This just shows up as a live process. You do PS, it seems cool. You try to kill it, it doesn't die. It's kind of like this kind of weird immortal thing.
So it's an asshole. It's an asshole, basically.
Yeah,
What it is.
maybe a vampire, right, can only be killed with like a stake to the heart and chop off its head. I know that. Yes, you can use all kind of. I guess, but the Nazgul is good because the only person who managed to solve it could actually say that she is no man.
There you go. Yeah, and I'd be worried about vampire processes anyway, because the only way to solve it, you just see the the SRE going into the server room with a wooden stake and a hammer. Like, is this going to have some permanent, repercussions to our infrastructure? It's worth it.
Yeah.
Yeah. So, if I'm getting this correctly, if I want to have code that is persistently running and not to be disturbed at all, I should use multiprocessing and multi-threading at the same time, right?
It's weird because it's not gonna run properly either. Because the main process is not gonna actually do anything, and the threads might like. I wouldn't use it as a feature, is what I'm saying.
Well, but what if my code is the nicest code of them all, and I don't want anybody to interrupt it?
Yeah, this is like a lot of like the scene from Lord of the Rings, where Galadriel is talking about maybe she's not gonna take the one wing. Even if your code is very nice, eventually that's like using the one wing. Eventually, all will fear it.
One does not simply use multi-threading and multi-processing together.
Indeed. I think we kind of ran the gamut of like the entire kind of obscure nerdy references in this in the description of this bug.
Yeah, absolutely. Well, in this course of this conversation, we have spanned just about anything. So I'll close it out. With the last missing reference would just be "May the Force be with you," because we haven't mentioned Star Wars yet. And Moshe, it was great. Great talking with you, and thanks for meeting us here for some coffee or tea in your case.
It was definitely my pleasure. Great tea and great conversation.
Hope to see you soon in future.
Yep, definitely.
Oh, and my ride's over there if we wanted to go check out that
Yay!
museum.
Free ride and free museum.
Yeah, definitely.
Absolutely,
I look
it's a
forward
bit.
to seeing you there.
Yeah, it's the closet. We can all go via closet. It is bigger on the inside.
Sounds good.
Hi, Bug Hunters Cafe. Marta speaking. We are located online at bughunters.cafe and on Twitter, Dev, and Instagram as Bug Hunters Cafe. Our galactic coordinates? I'm not sure. What are galactic coordinates?
I have no idea. The unicorn won't tell me.
I'm sorry, we're not sure. Folks usually arrive via portal. The music? That's provided by audionautics.com. We have a link on our website. No, we don't know their galactic coordinates either. No problem. Goodbye.